You might know from previous videos that the derivative of two functions multiplied by each other is equal to f of x times g prime of x plus g of x times f prime of x, right? Not too challenging. I mean, it can get a little complicated as you have bigger expressions for f of x and g of x, but the idea of the product rule isn't too bad, all right? But what if you have the case where you are dividing two functions, right? Well, you can rewrite this as f of x times 1 over g of x, and you could take the reciprocal of g of x, take the reciprocal, not the inverse, the reciprocal, and use the product rule as usual. However, there is another formula or another way you could go about finding this derivative, and that's using something called the quotient rule. The quotient rule can actually be derived directly from the product rule itself. So if I have f of x over g of x over here, right, this could be f prime of x times 1 over g of x plus f of x times the derivative of 1 over g of x, right? The derivative of 1 over g of x is a little weird, right? It's the negative g prime of x over g of x squared. If I were to substitute g of x is equal to u, I would take the derivative with respect to x of 1 over u, and this in turn would be equal to negative 1 over u squared. Keep in mind this is u to the negative 1. This negative 1 hops down. You're subtracting 1 from this power to get negative 2. To get negative 1 over u squared. All of that times du dx. This is a part of the chain rule right here, so don't worry about it too much, but you're just multiplying the derivative of the inner function by the derivative of the outer function. We'll get to that later, but for now, just take in that this is the derivative of 1 over g of x. And let's continue with our merry way, right? So f prime of x over g of x minus f of x g prime of x. Keep in mind, this is negative up here, right? All of that over g of x squared. If I were to multiply both the numerator and the denominator of this over here, I would be left with f prime of x, g of x, right? And now I'm just going to combine these two numerators here. So f of x, g prime of x, all of this over g of x squared. Right here, this is your quotient rule. All right, let's try an example here. Let's do h of x is equal to x squared plus 1 over x, right? You can consider this as your f of x and this as your g of x. It's important to note that g of x cannot equal 0 for the quotient rule to work, but let's continue on. So h prime of x is equal to the derivative of x squared plus 1 times x minus x squared plus 1 times the derivative of x over x squared. Okay? So this is equal to 2x, right? X squared, 2 hops down, and then this 1 goes to 0, right? Times x minus x squared plus 1 times 1, right? Derivative of x is just 1 over x squared. And this is equal to 2x squared minus x squared minus 1 over x squared. Okay? And simplify this further, 2x squared minus 1 over x squared. Right? If we were to simplify this from the get-go, we would get x plus 1 over x. If we were to take the derivative of this with respect to x, we would get 1 minus 1 over x squared, which is also equal to x squared minus 1 over x squared. There you go. Same answer as we had before.